Welcome to this Digital University 2024 session on solid edge sheet metal with myself, Chris Morgan. I also presented this with my colleague Benjamin Knowles on the 10th of July 24 at the British Motor Museum. So the agenda for today's session is General and Advanced Sheet Metal. We're going to look at working with imported data. We're going to look at some sheet metal enhancements in 2024, solid edge inspector, how we can use this with sheet metal items, sheet metal simulation, and we're going to have a little look at a customer success story. So I'm Chris Morgan. I've been at Amixa for 7 years and previously 10 plus years as a design engineer. My title is Principal Design Consultant, so I look after support, training and pre-sales, and my areas of expertise are solid edge mechanical design, part sheet metal, assembly, tubing, frames, etc. Solid edge simulation, piping and tubing, P&ID, and currently learning Flowmaster as well. Keyshot, Team Center Share and Solid Edge Data Management, Solid Edge Technical Publications, Solid Edge Inspector, Solid Edge 2D Nesting and Zelex. I presented this with Ben, my new colleague who's done 3 years at Amixa, 14 as a design engineer. He knows mechanical design, simulation, express route, frame design, and also Team Center, so very good new addition to our team. So what we're going to learn during this session: overview of the basic solid sheet metal tools, useful for new users. A run through the more advanced tools in solid sheet metal, great for existing users. How to import, convert and generate flat patterns from non-native CAD files. Family of part enhancements in 2024 that were based mostly around the sheet metal tools. Savers mirror part, which is available now in Solid Edge 2024. Why we use dedicated sheet metal tools. And a quick look at Solid Edge Inspector for sheet metal tools. So first we're going to have a look at the basics. So the base features that we start with, depending on whether we're ordered or synchronous, slightly different. We're going to have a tab, which is just like a flat sheet. Contour flange, it's like a kind of flowing sheets and bends. Or a lofted flange, we've got 2 open profiles and we put a flange between it. Lofted flange is ordered only. And then we can create additional flanges once we've created these. So we can create the contour flange, the flange command, and in ordered we've now got a newish command called multi-edge flange, where we select several edges at the same time and it creates the same size flange for every edge that we select. Once we've created our kind of major features, we can then do additional features. Hem, which will create a safe edge, or we've got 7 different options we can use for a hem. We can create a bend, so if we know what size something is going to be, or we know where we want to bend, we can go and bend it. We can unbend and rebend, so we can unbend, put a cutout in, rebend it, and see what it's going to look like. We can do a joggle, which creates 2 extra flanges and 2 bends based on a single line, so it'll create 2 90-degree, and then we can also close our corners with both 2 and 3 bend corners. So let's have a quick look at those in action. Okay, so our tab command. So once we've drawn our item, works same in synchronous order. We select our profile, choose our direction up or down, input our material at that point, and then right click to confirm. Very simple on that one. If we do this in synchronous, any dimensions translate from the sketch to the model and we can use that to control the model. Next, the contour flange. Again, we can look at synchronous. So we've got our sketch, click on our profile, choose our direction, we want our material inside, outside, define our material thickness, choose the symmetric extent if we need to, input our value, and again our dimensions are going to come across. Now notice this one we're in ordered, and this is the lofted flange. So we've got 2 open profiles. We choose the profiles, being very careful that we kind of do vertex mapping, choose the thickness and the direction, and select. Once we've done that, we can go into our options and we can choose our bending methods, and we can create all sorts of different options. We can show bends or we can show bend lines on there depending on what option we do. Notice this will create little cutouts to make sure that the CAD can create this as well. Okay, so next let's have a look at creating flanges. So now if we select an edge in synchronous, it will allow us to go and create a flange. If we select 2 edges and select the small arrow, this will allow us to go and create those flanges as well. If we input the sizes, that will create the flanges. We've also got the flange command. My layout's slightly different, but this one allows us to go and change the sizes, and this kind of creates the sketch for us on here. We can also do the multi-edge flange. So depending on where we select, depends on the direction. So these 4 edges I'm going to select up, and these lower edges I'm going to select the bottom edge. So it's going to go the direction of which edge we selected. the size is going to be exactly the same, the angle is going to be exactly the same. So if you want one flange to be different, you need to select that separately on there. You have to be careful that we get some different options. There are also options where we can go and trim, so when those come together. Also got the option to put a gap in there if we need to on there. So let's look at a contour flange. So when we create a contour flange and we choose our sketching method, we can go and choose it. We start our sketch from the brown dot. I like to do this in a 3D orientation, allows us to clearly see what it's going to look like. We can then choose different options, to end or chain, and that will do that, and that will tidy all of our corners up for us at the same time as well. You see we've got some nice neat corners in there. Okay, so let's look at some of the rest of the features. So jog, here we select our edge, our direction, and then we can move that. So see, this is creating 2 bends and 2 flanges, retaining the whole position. That's the benefit of this jog. Next we're going to do a bend. So here we've got a sketch, and because we've got a jog in the middle, our extend profile option doesn't work. So what we'll have to do on there, if we want to go and bend this other tab, if we edit into this sketch, do a quick fence select, remove this connect relationship from this end, and then use the connect command to join this up to there. We could have just dragged the endpoint as well, but there's several different ways of doing the same thing. And now that's going to go and bend across on there. So next we've got, I want to create some safe edges on these that we just created. So we can choose the hem command, select the edge that we want. By default this is going to do like a 10mm edge. Once we've selected the one, we can accept and then go and choose the second edge on there. Next we've got some corners. So here, if we go and close the corners, we can go and decide what kind of gap we want, and we're going to get that corner. So let's go and do that one, and then the second one on here. What I've noticed now though is it's actually made a little cutout down here. So we need to kind of go back and let's go and make a change to these. So let's go back on this one, and we're going to choose an overlap and choose a different option. So here we're going to do a close with option. We're going to choose our under and our over. So our first one is under and over. Next we've got a couple of holes we want to put in. So we want to unbend this first. So we choose a flat edge and a bend, and that's going to flatten that section. We can then choose the normal cutout command, select these 2 circles. That's going to go and put the holes that we want, cut those in. We can then choose rebend. We can then just tap the A key, which is going to do all the bends at the same time, and that's going to go and pop everything back together on there. Let's go and hide the sketches just so we can clearly see what this looks like now. Okay, so what other tools have we got? So we've got the ones for kind of working with the main components. We've also got other options. We've seen a couple of these already. So we've got hole and slot. So we've just seen the hole command. This allows us to choose holes. One thing I do find that you have to be aware is that we've got all of the full part commands for holes. So if you go and put a counterbore hole in, if you put an 8mm counterbore hole, you might end up with a 13mm hole, because that's the counterbore diameter rather than the thread. So just be very careful with that. Slot command, you can just draw the center of the slot. That also means that if you create it as a slot rather than a cutout, that will allow you to go and constrain a bolt to the center axis of that slot. So it allows you to kind of show how it's going to work properly. We've also got 2 cutout commands. We've got a cut or a normal cutout. I tend to refer to the cut as a regular. So this is going to cut exactly as it is. It's not going to take into account this is a sheet metal part, where a normal cutout will. This means that it retains perpendicular edges, so 90-degree edges to the cut surface, so we can do punch and laser cutting without having to do any chamfered edges. Also got deformation features. So these tend to be features that are going to deform the material. So there may be thinning and stuff. Solid Edge doesn't take that into account, so we have to be careful with that. And also the position of where the tools need to go might not be fully calculated, so it does need a bit of knowledge to check that these work okay. We've got lots of different features on here. We've got a dimple, it's like a pressed section, a louvre, which is a little kind of raised section, kind of like a little air vent, a drawn cutout, very similar to a dimple, apart from it cuts out the face. We've got the bead command for kind of stiffening up a section. We've got the gusset command, which creates a small gusset on an edge to kind of add a little bit of rigidity on that gusset. We've got the cross break command, which kind of adds like a kind of like a cross shape on it and punches it out ever so slightly to kind of stop resonance on a flat sheet metal item. And then we've also got the emboss command that takes a different body and pushes that into the component. Also got some other commands such as an etch for etching text into a component. Rip edges, so that's this, if we've got a part and we're going to flatten that, we say, well, I want 2 edges coming together, I don't want to bend here. It's a tool that we can use for that. rounds, so we can add rounds on the corners. Rounds work really nicely because we can just fence select the corners that we want, and it will only pick up the thickness edges, like the 1-2 mil, depending on the thickness of the part. And they've also got the chamfer command, works same as the rounds command on there as well. They've also got the flatten command, so this allows us to save as a flat, have a look, and add specific treatments on there. So we're just going to have a look at what these look like, not kind of create them. So here we're using the model view palette. So if we go, we can see what a hole command looks like on there. We can see what a cutout looks like. We can see a normal cutout, we can see it's got a bend, so we have to do a normal cutout. Next we can see a dimple in the X shape. We can see a drawn cutout with a little oval shape on here. We can see a bead being used to create the Emixer X. We can see the louvre with some nice rounded edges on there. We can see gusset along an edge, so you can see we've done 4 along there. Here you can see we've got a cross break. This is shown by the sketch, and here we've got an emboss, again showing the X shape on there. And here we've got the Emixer etched in on here. Now we've got a round on this edge, we've got a chamfer on this edge, and then we've already created our flat pattern, so we can easily see the flat pattern. And here we've got different edges bent depending on if the bends are going to go up or down, red, green or blue, not red. So advanced tools in sheet metal. So there are some really nice tools. If you haven't got an exact idea what to do, one of my favourites is the convert non-sheet metal models. So this is in ordered. We'll also have a look at how we can do this in sheet metal. So here we can just create a shape that we want, just a square. We can draw lines of where we want the edges to come together, and then we can go and use this command to go and turn a basic shape into a sheet metal enclosure almost. So let's have a look at that in action. Okay, so we're starting in ordered. We've drawn a rectangle. We're going to go and extrude that, and then we're going to do this as a thin wall. So this kind of represents this exactly what the thickness is going to be on there. We don't necessarily need to do a thin wall, but this tends to be if somebody's gone and created a sheet metal item not in sheet metal, they tend to do a thin wall so it looks real. On the tools tab we've got the part to sheet metal command. So here we can go and choose all of our different kind of options that we want on here. Default it's going to be 1, 1. I normally start with 1 and go and change it afterwards. If we then select edges where the bends want to be, that's going to go and create a bend around that edge. If we click on an edge and click on the little icon on there, it allows us to go and choose what the bend radius is and what kind of relief we're going to have. We can also do similar with the corners with the little red dots to show what the corner treatments are going to be like on there as well. So these can be customized. Once we've done that, once we've right clicked to finish, we can edit back into this, and if we do want to do anything, so if I want to do a global corner treatment, I can easily say, well, I want a circular cutout with a gap on there, and that's going to go and put that corner treatment in there. These can also be flattened, so again on the tool tab we choose the flatten command, we can go and flatten, and we can choose any kind of corner treatment. So I'm going to do a radius. I'm going to do a much bigger radius just so we can see this on the corners. Normally you do a tiny radius just to make it safe. And you can choose this for the outside and the inside. And that's then going to go and add that once we've done our flat pattern. So you can see we've got our blue bend lines on there showing that, and our flat pattern blank sizes on there. Next, family parts updates in 2024. So family parts allows us to select several parts that are very similar with minor changes. Now in 2024 we can make more changes between these items than ever. So the additional items we can now change are the materials. We can change more file properties. We can have etches on or off. We can have a different flat pattern per item. We can have a simplified version per item. We can now use multi-body modeling, so we can go and choose which bodies we show in each version. We can have different coordinate systems to help us to constrain it potentially. We can have different reference planes, sketches, and the edit table has now changed ever so slightly. You can see we've got the options button has been added on there. Okay, let's have a look at this in action. So first you can see we've got 3 members on here looking on the right of the screen. And we're going to look at each member. We're going to create a flat pattern for each one. So we're going to choose center first. We're going to choose flatten. We're going to select a face and an edge parallel to the x-axis. and that has created this flat pattern on here. So options, we need to make sure that we've got our include flat pattern option in members. So now if we scroll down to our flat pattern, this is the center, so we only want this to be available in the center option. So we're going to suppress it in all but the center on there. So let's have a look at the left one. Let's go and apply the left one. So we're just seeing the left one. Okay, that's good. Check we've got the design body active. So that's the design body we want to create the flat pattern of. If we then go to our flatten command, do the same process, following that edge and then the x-axis on there, and then go into our table, and we've now got our flatten 10. So if we have a look on that, obviously this is left, so we're going to have it unsuppressed in left, and we're going to have it suppressed in every other version on there. Notice we can actually just choose suppress. That's going to unsuppress the other one by default. Let's do the same for the right hand side one. Again, let's double check that design body. So right, apply, design body 3. Let's activate that design body. Double click or choose the activate command. Let's go to our flatten command, choose our flat plate and our edge parallel to the x-axis. We've now got our flat pattern. Let's go to the table. We can see it's flatten 11 on the list. So this one we can see right, so we need to make sure that we suppress all of those apart from the right one. One thing that I always think, it's always good to kind of check that these are correct. So let's go back to the left and apply. Yep. Let's go back to the center and apply, and we've got those flat patterns on there. So let's go back to order and just double check. For each version we're going to get the correct flat pattern on there. Next we're going to look at creating handed versions with text. So here we've got a right hand version, we've got our plane on there, we've already created our left member. So what we're going to do, we're going to do our mirror copy part over to the other side, and we're going to remove the original one. So it's going to mirror it, but it's going to remove the original one. There are certain things, sketches and etches, that might not come across, so this is where the family of parts is going to be really useful. So in this left version we've got the etch, and we want to kind of suppress that in there. So if we choose the etch, we can suppress, apply that, and we've now got our left hand version. Let's go and create our sketch for our etch in here. So I'm going to use my coincident plane by axis, so we can go and choose that edge. So that's going to mean that my text will be perfectly in line with this dimple or bead, whatever we've got on there. Make sure that we choose the appropriate font and font style, and we're going to choose left, and we're going to constrain this up. When we constrain text up, we ignore the text, we just constrain the box like it's a rectangle. Very simple on there. Once we've got our sketch in, we can finish that. We can then go and find the etch command in the dimple drop down, choose the text and accept, and that's going to go and pop that on there. So let's have a look on there, make sure that we've got sketches which will control the etches within our family option. So let's go and have a look at our right one. So our right one, we can see obviously we've done our mirror, so we need to go and find out what we're doing. So we need to go and suppress the mirror. That's going to go and take that back to there. We've also got our left sketch etch on there as well, so we want to go and remove that etch and check that. So let's just check our left looks correct, yep, and our right was correct as well, and let's just double check. Next one, I'll look at material. So for each of these we can go and apply the material. Okay, so what we're going to do is just make sure these are all saved. So next we want to do these in different materials. So I'm going to add a little ST for stainless for each of these. So I've got a left stainless steel, and I've got a right stainless steel on here as well. Okay, and then we can go and change the material for each of those. So the one that we have active is going to be the one that we're going to go and change. So we've got our left stainless, left steel, right stainless, and right steel. Let's just check that these are all correct. Let's get stainless steel in that one, steel in that one, stainless in this one, and the last one was steel on there. Okay, we could also go and control variables if we needed any size changes, but we're not going to in this one. So let's just double check that these are correct on here. We've got our steel, and each time we change that and apply, that material is going to be applied. The best way is to look at the table and just double check that stainless steel has got the correct materials applied to each of those members. Hopefully that was useful. Next is the Save as Mirrored part in Solid Edge 2024. This new command allows the creation of a new part file containing a mirror of the current part. With the option link to original on, it creates a part copy of the current bodies in the new file. The part copies are the same type as the current ones, design or construction. With this option, only base reference planes can be used as input, as in the part copy command. The command has only been added to both the ordered and synchronous environment. You do have to just be aware sometimes when you've got data management running that it might cause some issues, so just be aware of that. So let's have a look at this in action. Only a short one, this one. Okay, so here we've got an assembly with a component in. Looks like a bit of a kind of guard for coupling or something. So if we go into that one, we can choose our save as mirrored part, choose our reference plane, and then we go and save our part on here. This one I'm going to choose this like the original way, so we're not going to have these linked up. But you can see how now we've got this part. It's available in there. We can choose our faces and go and constrain this up. Just flip that, select those faces, and we've got that part. So if we do go and change the one, we're going to get a link back to the other part on there. Simulation in solid sheet metal. So solid sheet metal is great because it's got specific tools, but it's also got specific tools. It allows us to use a surface, which means that we get fast simulation results. So what we do this, we create our surface mesh, we use what we call the mid-surface tool, and we can also use a command called override property that allows us to go, well, there's a part on here that's not as strong as it should be. What happens if we thicken this up? So it allows us to, in a couple of seconds, go and change the thickness of a part and resimulate that part. Let's have a look at that. So here we have a sheet metal file. The material has already been applied, but we need to apply the mid-surface. So if we go to the mid-surface option, choose the side by clicking the icon, and then choose the offset ratio. So we're going to leave this as 0.5 on here, and then we're going to preview and finish. Next, if we turn our design body off, we're going to see our thickness. We're going to choose our surface study, accept the body. I'm just going to quickly zoom through and create some little relationships. So the little blue dots are our fixed relationships, and then I'm going to apply some forces. So we're going to go 50 kilograms, 500 newtons on here approximately, and then we're going to have 100 newtons on here. And this is the one that's troubling me. This little tab on here. We've got quite a load on here, and we've got quite a thin section. So that's the bit I'm worried about. Over on the right, we can see how we've got our thickness, our geometry, our constraints. And if we choose mesh and solve, it's going to take literally 1 to 2 seconds. And that's then going to show our stress. So we've got a high stress point. We can see our red arrow on there, meaning that bit's going to have failed. And we can choose to animate that, show where that's going to move. So we're seeing this as displacement on here. Obviously we're showing this as a kind of ratio. It's actually moving more in the video than it really would. So that little point is causing the problem on there. So let's go back to our file and go to our animation, our override properties command, and we choose a thickness, and then fence select the item we want to go and override that on. So we're going to go from 16 gauge to 2.5 mil, and we're going to reprocess that. So here you can see our stress is now 286. It was about 718 before. It's probably not quite the factor of safety that I want. So let's go and up this to 3 mil and click solve again. So now we're down there, so we're kind of factor of safety of just over 3, which is what we're looking for. We can also show our plate thickness of what that's going to look like, and we can also show a ghosted undeformed model of how that's going to look on there. Really quick way of doing some simulating using those specific sheet metal tools. Solid Inspector. This is another 2024 update. Sheet metal files can be fully characterized like solid edge draft documents. Supported annotations are dimensions, feature control frames, and labels and texts. So let's have a very brief look at that. So here we've got a sheet metal file. First thing to do is check the tolerances. We've got different options we can go and choose. So I'm just going to stick with the medium one on here. We can create our own custom ones as well if we need to. Choose the auto ballooning. This is going to go and balloon all those items up. This is also going to go and create our kind of spreadsheet. Here we can go and change any options. So by default we've got our minor. If we need to go and change those, we can right click. Once we've made any of those changes, we can commit that, and that's going to go and make the changes on there. If we then update that view, that's going to go and change those, and the rest works the same as the normal part design one. Okay, here's one of my favourite bits now. Import, convert and generate flat in synchronous. So Solid Edge supports all the major CAD systems. If it won't come into Solid Edge, find a system that saves it out as step file. Pretty much everything will do step file. If it doesn't, it will do IGES or some other kind of file format. So what we tend to do, quick little process before we do the video, is open it as a sheet metal file. It's a sheet metal file. It's not really a sheet metal file yet, but we want it to be a sheet metal file, because one thing that Solid Edge does, it allows us to filter via sheet metal file, where if you go to most of the CAD systems, there's just a PAR, a PRT, a SLD PRT, or whatever it is, and the sheet metal files can't be just easily found, especially in Windows Explorer. And then we're going to choose Switch to. So we've created a sheet metal file, but then we're going to go back to the part environment. It's going to be saved as a PSM, but we're in the part environment. But then we're going to optimize the model, so that's going to look for any kind of faces that it can improve. And then we're going to use the thin part to sheet metal off the Tools tab. Once done that, that's going to go and convert that into a tab and loads of flanges. We can then go and recognize holes. We can use Selection Manager mode to recognize slots, cutouts, other kind of features. We can then recognize chamfers. We can select any kind of slots and turn that into recognized patterns. And then if we want, we can transition to ordered and do our normal ordered modeling in the way that we know. This process takes seconds, and then we're probably going to spend a lot more time transition to ordered, flat patterning, tidying everything up. So we've got some really good commands. Let's have a look at this then. Okay, so once we've imported that, we've got our body feature. So we're going to do our thin part to sheet metal. Here we've got some issues, so I'm not going to make it easy for myself. So I'm going to use the view cube, and I've got these dimples on here. So these aren't sheet metal items. So what we can do, we can use the detach command. So we can select each of these features and detach. I've used the view cube in the right hand corner and choose right, so it's going to pick that from both sides at the same time. Next we need to, let's go and do this again, and we're going to go and convert that. Now you can see on the left now we've got a tab and a load of flanges. It's really good, but we've still got our body feature. These are our items that have been disconnected on here. Recognise holes. You can see we've got 128 small holes and 8 larger holes. But we also have to inspect it as well. We don't know that the person that's designed this understands sheet metal fully. So we're in synchronous mode. So I can click on a face, drag it to a key point, and then go and drag that face, kind of make a bit of an estimate. Let's move it 2.5 mil. That's going to allow that little tab to go flat on there. Let's go and check our flat pattern now. So if we choose flatten, select our face and our edge, you can see we've got our colours, we've got our holes all in there. So within less than a minute we've gone from a done part to an item that we can now go and manufacture. We can then turn on the body feature, so we can see these features. These aren't sheet metal items, but they're great placeholders. So if I want to go and do a specific profile, I can go and recreate those features on there if I need to. Okay, next. Unfortunately I haven't got Glenn here to talk, so I'm just going to talk on his behalf. So Shepherd Innovations is engineering, design, robotics and 3D measured building scanning company based in the Midlands. They specialise in customised solutions to problems, from bespoke tooling jigs to automation with robots to entire machines for industries such as automotive, aerospace and food and beverage. As well as designing projects for clients, they've created them for their own use, so we understand why reliability of manufacture and ease of assembly are so important. During the presentation, Glyn went on to say how sheet metal is so useful because it's so cheap, so quick and so strong. We see a lot of people coming up, oh, I want to 3D print this, but to get it at the price point and the strength of a sheet metal part, where you've got the manufacturing facilities to be able to do it quickly, sheet metal really does offer a great strength to weight ratio compared to a lot of other manufacturing methods. Okay, so we've looked at advanced and general sheet metal, importing parts, family part enhancements, so as mirror parts, Solid Inspector and Solid Edge Simulation. Thank you very much. Here is mine and Ben's email.